Hello everyone, in this video we are going to give a complete review of quadratic functions in vertex form, how to find the vertex, how to find the axis of symmetry equation, how to find the domain range, the direction of opening, maximum minimum point, and everything that we need to know in order to sketch the graph. So before starting the real problem, first of all I would really want to show you all that what is actually we are doing in the problem and what does each of the term means. First of all, in order to understand how this works, we have to understand two important graphs. One is called the maximum graph, the other is called the minimum graph. So this one is referred to as the smiley face when you smile, and this smiley face is the minimum graph. So make sure you remember that the smiley face is the minimum graph. You know why? Because we are happy the least amount of times in our life, and a sad face is actually a maximum graph. So first of all, are we clear about the concept? There is going to be two shapes of the graph. One is going to be a smiley face and another is going to be a sad face. So this is the minimum graph, the happy face is a minimum graph, and the sad face is a maximum graph. Alright, now let us move on to certain terms. First of all, if you observe the graph very well, may it be a maximum graph, may it be a minimum graph, there is actually a point in the graph after which the graph actually starts to turn back. Do you see that? The graph is moving like this, the graph is moving like this, and then as if it hits somewhere like a wall and it's reflecting back again, right? So the point that it starts to reflect back, we call it the vertex. So let me tell you, the case is also same whenever we are dealing with a maximum graph. It's gonna hit a point and then it's gonna be reflected back like this. This is sometimes referred to as the vertex. This is sometimes called the turning point. This in many physics textbook, when you deal with quadratic functions, this is also referred to as stationary points. So there are a lot of names, but for this chapter we are going to utilize the name vertex. So I hope you are clear about what is actually vertex. Now let me come to the second important term. What is the axis of symmetry? Now many people just directly uses the formula to get that, but I will be teaching you the real concept of what it actually means. Okay, now there is a formula for vertex as well, which I will be showing you later with the expression. First learn the different names. So the axis of symmetry is a line which will divide the graph 50-50. So let me repeat one more time. So axis of symmetry is going to be that line which is going to cut the graph into two equal parts, 50-50. It may be a maximum graph, may it be a minimum graph, so it's a line which will be cutting the graph into two equal parts. So this is what the axis of symmetry means, and there is a straightaway formula from the vertex form. Now let us come to the next important term, the y-intercept. Now you know already, if you have learned x-intercept, y-intercept and graphs, that y-intercept, suppose I have a line like this and the line moves like this. So the line, whenever it cuts the y-axis, we call it the y-intercept. Alright, so if you observe very well, what value is 0? Suppose if this is 0, this is 1. If you want to plot the y-intercept, how it's gonna be 0, 1, correct? So whenever it cuts the y-axis, the value of x is always 0. If you observe very well from the graph, right? So whenever we'll try to find the y-intercept, the value of x should be 0. Now let us move on to the next part. how to find the x-intercept. In order to find the x-intercept, so now we are going to know how to get the x-intercept from here. So to get the x-intercept, we have to realize that we are going to be drawing a graph, and we see that whenever there is an x-intercept, the value of y is actually 0. So as a result, we get the value of y as 0 whenever we are doing x. So now, as we are doing the x-intercept, our value of y is going to be 0. Now we are left with three important terms. One is called the maximum or minimum point. Now I hope you already know by my explanation that depending on the nature of the graph, if the graph is going to look like a smiley face, then you will have a minimum point, and minimum point is nothing but actually the vertex, right? And it's actually the y value of the vertex, because the y value is telling you how much it is going down, right? Similarly, if it's a maximum graph, then instead of maximum point, instead of a minimum point, you're gonna write the maximum point over here, and it involves the y value of vertex, to be more simple. Now after this, we have two important terms that we must know. One is called the domain and another is the range. Now for domain, you must always know domain are those values of x. I repeat, domain are those values of x for which the graph will exist. Now if you observe very well the quadratic graphs, you will always see that there are two arrows like this. May it be a maximum graph, may it be a minimum graph, because it means that the graph is going to continue forever. So no matter what is your value of x, you always have a value of y. So this is how you are going to get the domain. Whatever is the value of x, you still have the graph line existing, or the part of graph existing. As a result, you can memorize or you can remember like this, that x is going to be a function of all real numbers. So this is how we represent the domain, and it is same for the maximum or minimum graph. So the range of the function. Now to get the range of the function, you need a little bit of visualization. How to visualize that? Say for example, my graph is moving like this, and say this point x is 3, y is -1. Alright, so domain actually gives us the x value, but the range will give us the y value. Alright, so we have to write y. Now observe this very well. What's the value of vertex over here? 3, -1, correct? It's still the y value of the vertex. So y, and I write -1. Now observe the graph very well. If I move my values above -1, is my graph existing? Suppose I'm taking a point here. Is the graph existing? Yes. If I'm moving up, greater than -1, my graph is existing, right? So the range would be y is greater than or equal to -1. Now, if I go below -1, are there any part of the graph with me? No, right? As a result, the range is y greater than -1. Now, let me show you the full form how it works, as we learned all the terms that we needed. So, let us move. Now that we have learned all the different things that we need to know, we are gonna go with the form y equals to a x minus b whole square plus q, and this is referred to as the vertex form of quadratic equation. Now if you could recall back whatever things we have learned so far, that we have a maximum graph and a minimum graph. So by looking at the value of a, you can determine the shape of the graph. If a is greater than 0, the graph is going to be a minimum graph. If the value of a is less than 0, the graph is going to be a maximum graph. So make sure you note down the value of a as soon as you see a problem. Alright? Then we can find the vertex by using the formula directly, which is going to be p comma q. Make sure you note this one down. And then we have a formula for equation of axis of symmetry. And the formula is going to be x equals to p. And the third one that we need to know over here is the x-intercept, y-intercept. So we will just insert the value of y equals to 0 to find the x-intercept. The point it will cut the x-axis. The point it will be cutting the x-axis. Also we need to get the y-intercept, which is very easy. Just put x equals to 0. This both work will be done in the main equation over here. Okay, so the domain is fixed, as we already know, where x is a function of all real numbers. And range, as I have already shown you, is the y value. It can be greater than, or the y value it can be less than q. Q means the value of q in the vertex. Now these are the formulas that we need to know, and now we are going to see a problem based on this. And the problem which is given to us is right now y equals to 2x plus 1 whole square minus 3. So the point is this, that this is going to be my value of a. You have to match the equation. A over here, do you see? Ax minus p whole square plus q. So a over here, and this is definitely x minus p whole square plus q. Now here is the tricky part, because the expression itself have a negative sign here, but you have a positive. So first of all, you have to get the value of the three important things we need to know: a, p, and q. And I always advise you not to skip this particular line. A is going to be 2, so you know it's going to be a minimum graph, right? So the value of p is going to be -1, and the value of q is going to be -3, right? So we got the value of p and q, so very easy problem for us. Just we put the formula vertex equals pq. So we know the vertex is going to be -1, -3. Easy to do, right? Now we also know the equation for the axis of symmetry. So the equation for the axis of symmetry have a straightaway formula, which is x equals to p. So x equals to -1. So you got two important information already. Remember, we are going to use all the information finally to sketch the graph. Next we need to know is how to find the y-intercept. To find the y-intercept, we must always put the value of x equals to 0. So this is the equation, and I'm gonna put the value of x equals to 0. So 0 plus 1 whole square minus 3. As a result, I'm going to get 2 minus 3, which is -1. So I got a point over here. When x is 0, my value of y is going to be -1, right? So remember, make sure you always make it in the form of coordinate, because it will make your life easier when you sketch the graph. Now, for finding the value of x-intercept, you already know that the value of y is going to be 0. So for x-intercept, we write y is equals to 0. If this is the case, then let's put y 0 in the expression. As we do that already, like this, we get to expand. Now this is the part which is most concerning for some of you. If you have remembered a plus b whole square, we will be ending up with either two of them, either a plus b whole square or a minus b whole square. So I clarify you this: if it is a plus b whole square, a square plus twice ab plus b square. If it is a minus b whole square, it's a square minus twice ab plus b square. Here there is an addition, so we are going to break it down to 2 times x square plus twice x plus 1 and we have negative 3 equals to 0. Now, if you observe the expression very well, you're gonna see that this 2 is in form of multiplication with all the other expression numbers, right? As it is in the form of multiplication, so what we're gonna do right now, we will multiply. As we multiply, we see that we are going to get 2x squared plus 4x plus 2 minus 3 equals to 0. Or we will get 2x squared plus 4x minus 1 equals to 0. Now as we end up with this sort of an expression, we will be then using our calculator to get the x-intercept. And how is that possible? It's very simple. We will just take our calculator and insert the equation form. As we do that, we will get the value of x, a value of x. We're gonna get two values of x. One would be over here coming as so right now we got this as an equation and we're gonna put it in the calculator. So let me show you how this is done. You go to mode, you get equation over here, press 1. It's a 2-degree equation, so you're gonna press 2 over here. A is the first number, which is 2, B is gonna be 4, and C is gonna be -1. So this is my first number, which is the x-intercept, and the second one would be -2.22. As a result, I have two coordinates right now. When x is 0.224, my value of y is 0. When x is -2.22, the value of y is 0, right? So these are the coordinates that I have got, and I have already made the boxes, right? So remember, this is my vertex. This is gonna be the equation for axis of symmetry. This is going to be the y-intercept. This is the value of the x-intercept. Now I'm left with two important part of my problem. So how to do that? Let me see whether I can do it here. So now I have got all the coordinates that I need, right? So now I need to get the domain, and I'm pretty sure we all know the domain, why this happens. X is going to be a function of all real numbers, and we have to find the maximum minimum, right? So now let us sketch the graph first. So let me draw it like this. I think it's visible over here. Now we are gonna plot all the points, but be more tricky here because we are gonna first plot the vertex. So the vertex is when x is -1, y is -3. So the vertex is going to be somewhere here. When x is -1, y is -3. So somewhere here. So I label it already. Now we have the, so this is done already. Now I have the y-intercept. So what's the y-intercept? When x is 0, y is -1. So when x is 0, y is -1. So x is 0, y is -1. Of course, this is my y-intercept. Now I have to utilize the value for my x-intercept, and it's going to be when x is 0.224, y is 0. So it should be somewhere really close to here actually. So it's a positive value, so I will label this. Similarly, I'm gonna label this one. This will be quite a far away point because it's -2.2. So -2.22 comma 0. As a result, I have already plotted the points I need. Now I'm gonna sketch a graph. Before sketching, I already know my value of a is 2 over here. If the value of a is 2, we know the shape of the graph is going to be a smiley face. As a result, I'm now gonna just join all the points together and give an arrow like this. Sorry, no space over here in this side. So I'm gonna give an arrow like this. So this is how I will complete my drawing of the graph. But remember, I'm forgetting one important thing, the axis of symmetry, which divides the graph into two equal parts. So this is gonna be the equation for axis of symmetry, and I have to label it as x equals to -1. So this is gonna be the equation of axis of symmetry. Now I need two important things. One, is it a minimum graph or a maximum graph? It's a minimum graph, so it will have a minimum point. And what is that minimum point? -3. So I write -3 here, the Q value of the vertex. Secondly, what's gonna be the range? The range is very simple. It's gonna be the value of y, and I will always write the Q value of the vertex one more time. Now just look at the graph. If I go above -3, is my graph existing? Or if I go below -3, where is my graph existing? Just check using an arrow. -3, above -3 we have part of the graph, right? Below -3 we have no parts of the graph. So the graph will exist whenever the value of y is greater than or equal to -3. So this is how we do the problem based on the vertex form of quadratic equation, a complete package of everything over here. So I believe you enjoyed the video and you have understood clearly how to draw the quadratic graph whenever the vertex form of the equation is given. In my next video, I have shown how to convert the standard form into a vertex form, and then you can follow the procedure which I have followed over here to get to the sketch of the graph.